In this video, we are going to discuss about cascade realization. So consider the transfer function h of z. Here the h of z is converted into subtransfer function. Okay, whatever the possible transfer function you can split up, you can split into that much transfer function, and you have to realize the each transfer function separately in direct form too. Now consider, for example, h of z consists of two transfer function. I am going to realize this transfer function in direct form too and this in direct form too. Okay, see this. So here how many delays are there? I have drawn two delays. So here the numerator coefficient is bk0, bk1, bk2. Then I have added using adder. Then here it is denominator coefficient is minus ak1 minus ak2, so I have added using adder. Okay, similarly I have realized this. So numerator coefficient bm0, bm1, bm2, denominator coefficient is 1 minus am1 minus am2, so I have cascade it, and I have given an output of one as an input to another. So I have realized the cascade realization. For parallel, you have to draw this structure here and you have to combine both the input and the output. So now consider this problem. In order to draw the cascade realization, the first step is you need to have transfer function. So I have applied z transform and I have applied and I have obtained the transfer function. Now I have obtained this transfer function h of z. So I have factored the denominator and I have written in these two factored form. So I am going to consider this one as a h1 of z and this two as a h2 of z. Either you can have for this also, that's up to you. So you can that you can write here also. Here you can write 1 by 1 minus 1 by 2 z inverse. Now I am going to realize this. So first see how many delays are there. Only one delay is there, so I have written one delay. So here this side you are going to realize the numerator coefficient. So here it is 1. So here it is 1 by 3. This side you are going to realize the denominator coefficient. Here it is minus 1 by 2. So plus 1 by 2. So I have given the input x of n. So here I am going to add with using the adder. Then here here I have realized this. Now I am going to realize this one. So here I am going to draw one delay because here it is only one delay, and numerator there are no coefficient, only one part is there. Here it is 1. So at the denominator I am having minus 1 by 4, so it is plus 1 by 4. So what I am going to do is I am going to have an adder in order to obtain output of this and the input to this. So the output of this is fed back and I am going to have the output y of n. Okay, so this is what the transfer function realization for a cascade form. So see, consider the transfer function here. So what I have done is I have factored these two. So here I am going to consider this as one transfer function and this is another transfer function. So I am going to realize this. So first one is z inverse. Okay, so the numerator coefficient, this side I am going to realize. Here it is 8. So here it is minus 8. So denominator coefficient I am having plus 4. So here you will have minus 4. Then I am going to add using the adder. So this is what your x of n. So here also I am going to add using adder. And then similarly here I realize the transfer function in another function. Z inverse is the common factor. So numerator you will have 1. And the and also you will have minus 1 here. At denominator you will have 2. So here minus 2. So adder. So I am going to add the output of previous transfer function with this. Okay. So now I am going to add these two transfer function. So here this is what your output y of n. So this is what the procedure to realize the cascade form. Now consider the parallel structure. Now say the same structure what we have realized in cascade. I am going to here this cascade realization, the same cascade realization I am going to have realized in parallel. So consider this one, that is 1 plus 1 by 3 z inverse divided by 1 minus 1 by 2 z inverse. So what I have done is I have considered that same transfer function. So this is the form I have realized in cascade. Now I have realized here, then I have realized this one, and I have given as a combine the input and I have combined the output using an adder. Similarly consider this problem in cascade realization. So the same thing Here I have considered this as a one transfer function. I have realized this, and I have considered this as an another transfer function. I have realized this. The procedure and all, you know, just you need to cascade, that is you need to draw as a parallel. So input, both input should be same. Here the output should be combined, and you have add using the adder. Okay, so this is from the realization procedure for direct form, sorry, for digital IIR filters. Hope you have understand these concepts. So I will give some tutorial problems for you. You will just solve it and you have to submit it. Thank you.